Okay, so we've worked out how to find the sample space from a two-step experiment. Now we're going to look at using that sample space in order to calculate probability. So if I go back to my original array, this is from my first cup and my second cup. How can I work out the probability of any particular combination happening? What if I want to know the combination of blue then green? Oh, sorry, blue then red. Okay, so I look at what I've got. Blue then red, blue then red. That appears here in my array. It only happens once. There's no other combination written here that looks like my blue then red combination. So the probability, if you remember, of any outcome is the number of ways that that outcome can happen. So the number of ways blue then red can happen divided by the total number of outcomes in the sample space. So there's one way that blue then red can happen, and there are 8 different things in total that can happen. So the probability is 1/8. How does that look on my tree diagram? Exactly the same. Blue then red, that just happens the once. So there's one tick out of a grand total of 1, 2, 3, 4, 5, 6, 7, 8 finishing branches. So that would be how I calculate the probability there. But we have to be careful. This only works when every outcome is equally likely. At the moment, when I dip into here and I choose a color, I've gotten blue, but the chances that I got green or brown or yellow are all equally likely. There's a 1 in 4 chance of getting each color. In my second bowl, oh, I got a white this time. There's a 1 in 2 chance, a 0.5 chance of getting white, and a 0.5 chance of getting red. But what about now? Now, even though my tree diagram looks the same, I've actually got a different probability on each branch. This is less likely to happen than this each time. So let's look at that. Here you can see that my probabilities in this cup are not equally likely. I've put 3 reds and 2 whites in. So what might happen? I'm going to close my eyes, draw something out. Oh, I got a red. I'll do it again. Oh, I'll put that back first. Swirl them around, pull one out. I got a white. So this time I got a red and then a white. But what is the probability of that happening? This is a 2-step experiment because I pulled out one color and then a different color. It doesn't matter that I used the same cup. It's still a 2-step experiment. So first of all, let's look at it as an array. Here's my array with every possible outcome. Now I've got 3 reds, so there's 3 reds. That's my second step. So the first step, I could have pulled out any one of 3 red pieces of Lego and any one of 2 white pieces of Lego. And in my second step, 3 reds and 2 whites again. So then I listed all the possible outcomes. Red then red, or red then red, or red then red, and so on, or red then white. But I'm interested in the probability of red then white. So how many outcomes have I got altogether? 5 by 5. I've got a grand total of 25 possible outcomes. That's if I count this Lego piece as different from this Lego piece, which it is. All right, so I've got 25 possible things that can happen. How many of them look like this? Red, then white. 1, 2, 3, 4, 5, 6. So the probability of getting red then white is 6 over 25. But that's a pretty annoying way to have to calculate this. I had to draw a whole grid and I had to have 25 places in my grid. Now imagine if I'd had 50 reds and 25 whites. I don't want to have to draw a grid that big. We've got another way of doing it. And this is how we'll usually do two-step experiments where we don't have equally likely probabilities for each outcome. Red, in this case, is a different probability than white. So what I'm going to do is draw a tree diagram and look at all the possible outcomes. The tree diagram, from my first time I pull out a colour, what could it be? Well, it can be red or white. The second time I pull out a colour, again, it can be red or white. Doesn't matter what happened the first time, red or white, red or white. So it still looks like a tree diagram, but here's the important difference. I'm going to actually include the probabilities in my diagram. So the first time when I pulled out a red, the probability of that happening was 3 out of 5, because there are 3 red out of 5 Lego pieces. If I had pulled a white out the first time, my probability would have been 2 out of 5. Now let's just check that these two add up to 1. 3 out of 5 plus 2 out of 5 adds up to 5 out of 5. Yes, it does. Okay. Let's do the same for the second time. If I had pulled red the first time, which I did, what's the probability of pulling red the second time? It's the same, 3 out of 5. And this didn't change either, because I did put my red piece back each time, so the probabilities of red or white didn't change. And this is how I do my calculation. I want to know the probability of getting red, then white. So I follow my tree. Let's do it in red to show it. I follow my tree from the starting point to the first step, which is red, and then along the branch to the second step, which is white. And what I have is 3/5 for the first step and 2/5 for the second step. Okay, now if I go back to my array, that's the equivalent of having 3 out of a total of 5 here. So I've got 3/5 of this big block here. So that got me 1, 2, 3. That was having red first. And then 2/5 is this second step. This white was the 2/5, 1, 2. So if I want to calculate this area here as a portion of the whole, it's multiplication, 3/5 times 2/5. It's going to give me 6/25. So I don't need to do that array every time. I can use a tree diagram. Let's do a different example. Okay. I'm going to draw 2 pieces from here, and I'm going to calculate the probability. Now, you can see there, I've got 4 red, 3 white, and 1 purple. Let's do a 2-step experiment and see what we get. First time, I'm going to pull out a white, put it back. Second time, mix them up, I pull out another white. All right, let's work out the probability of this happening. This time there are going to be 3 branches on our tree for my first step. 1, 2, 3, because there are 3 different things that can happen. It could be red, it could be white, or it could be purple. And let's put our probabilities down. Probability of red, there are 4 red out of 8. 4/8 equals 1/2. Okay, probability of red is 1/2. Probability of white is 3 out of 8. Probability of purple, 1 out of 8. Okay, now when I pull my second one out, same probabilities because nothing's changed in there. So again, red, white, purple, red, white, purple, red, white, purple, 1/2, 3/8, 1/8, a half, 3/8, 1/8, a half, 3/8, 1/8. So if you're ever asked to draw the tree diagram, this is what it looks like. It's got all the branches that I need, and it's got all the probabilities filled in. And on each section of these branches, my total should add up to 1. 1/2 plus 3/8 plus 1/8 does add up to 1. But I'm looking for the probability of getting white, then white. So I go here to white, and then I travel out to white again, and I end up with 3/8 times 3/8, which gives me 9 out of 64, and that's my probability. Okay, so the probability that I get white, white is 9 out of 64.